Hi. So I'm Andrew Lamb. I'm a developer. I've been a developer at Vertica for 5 years now. And so therefore, I'm not a sales guy, so I'm not good at giving sales pitches. So this won't be a sales pitch, at least not really. We have Yogesh down here in the front if you do want a proper sales pitch. Instead, I'm going to give you a very, very minor pitch, which is basically for Vertica. What I thought I was going to have to convince you all is that there's not a problem with SQL databases for very large-scale analytics, right? The problem was the existing implementations designed for transaction systems. And that if you did, proper architectural design and made the right trade-offs, that you could do quite well with a relational data management system on these really large volumes. So first of all, you don't have to take my word for it. We have a free version, the community edition, that works up to 1 terabyte, so you should download that and try it if you'd like. And I also thought I was going to have to justify why you should listen to what I was saying. But given the prior talks, I feel like you've actually seen there's several customers that do real things. But anyway, here's some metrics nonetheless. Right, so we have over 600 customers. We have at least 3 customers. If you've been paying close attention, you might guess who they are. Right, at least some of who they are that have over 1 petabyte in their actual production instance. Right, so this is a petabyte of raw data running in a system that's not just getting dumped somewhere, but it's actually also actively getting queried. And then likewise, we also have a customer that has 10 trillion rows. So I wrote down the number of zeros because it's actually quite impressive. It took several years to get there of a continuous loading. But so we know something about scale. So that's basically the last specific pitch I'll give about Vertica. And the rest of the talk I want to spend describing how you choose among different systems that have been mentioned here over the last couple of days, right? Especially because I think there's still a significant amount of confusion. So the systems I chose were massively parallel, right? There's these MPP, that's what it stands for. I don't know if anyone ever defined that. Right, it stands for massively parallel. That's basically distributed systems. They don't have a shared disk. That's why I don't talk about some of the things like Oracle. So I'm going to compare parallel database systems, ourselves, of course, Vertica, and then also Greenplum, and Teradata you might also classify here. Then I'll talk about Hadoop, Hive, Pig. Conveniently, those were also just described, right? But I'll give a brief recap again. Hive is a SQL layer that you write SQL queries, compiles down to MapReduce jobs, and runs on the Hadoop infrastructure. Pig is a data flow language that, likewise, you write your jobs in and it compiles down to MapReduce. And then, while it's not really an analytics system, we get asked non-zero amount of times, like, how do you compare your system to HBase? So I'll try to point out, like, the kind of workload HBase is good for. It's not the same as analytics, at least not in my book. So the first thing, I probably got the finance things wrong, but basically I think this is one of the key differentiators between all these different systems, right? And it's basically how much money and time does it cost you to get going versus how much time and money does it cost you in ongoing operations. So there's certain projects that you can get money up front, pay for enterprise software, which unfortunately is expensive, that you have to pay before you move into production. But the upside is that your ongoing cost is lower, right? So, and I list reasons why I think that is. I'm not sure this is worth talking too much more about, other than part of the initial cost is licensing fees, but the other part of the cost is you got to come up with exactly the schema you want. Yeah, sure. Sorry. All right, so the next thing I want to talk about is when you compare these systems, right, there's different ways to query the data, right? One of them, we've talked about, this is nothing new, right, but this is a way to think about it if you're thinking about how you want to do your analytics, right? One is this declarative notion where you basically specify the what you want, and the system goes, and you let the system go figure out how to get it, right? That's exactly what SQL is. It's that abstraction that's so powerful and why people have like SQL actually has had such significant success over the years, right? The downside is you better hope you can express what you want in SQL, right? And for certain things, it's very good, very expressive. And for certain other kinds of computations, it's either cumbersome or impossible to express what you want. I've also found that this is SQL and other declarative languages are preferred by non-programmers because you don't have to learn to program. So the other alternative is you get a procedural system like Hadoop or Pig or HBase, right? Well, HBase maybe not, but you have to explicitly specify how to do the computation in addition to what you want. So the upside of that is you can make it do exactly what you want, right? The downside is you have to be a programmer to know how to do it. And anytime you want to change the computation, you got to go change the programmer. I found that this is actually, if you start off as a programmer, you often prefer these systems at first, which I think is why they got such wide play in a bunch of these startups, right, where you just have programmers. But over time, even I as a programmer, right, like got sick of writing little Perl scripts to compute averages, this, that, and the next way. So over time, I think you can convince people to use declarative languages. Right, so now the next big trade-off that you make between databases and other non-database systems is performance versus flexibility. And I don't think this is magic, right? Like, I'm not going to be a marketing shrill up here and tell you that you can have both. Like, what you give up, Hadoop, you dump a whole bunch of data in, and you basically do late binding on it, right? So it just stores a bunch of bytes, and it's only when you go to look at the data do you actually have to impose structure on it. The thing is, that's not for free. When you store it in the system, now the system has no idea what's in there. That's flexible. It means you can store whatever you want, and you don't have to tell the system anything about it. The downside is the system has zero, or very close to zero, hope of doing anything to optimize for queries later on. Right? So you pay a huge cost in performance. And so like people have talked about that over the last couple of talks about, you know, if you're willing to pay the performance hit, it's a great system. But if you have, you know, you can do quite a lot better if you know something about the structure. But you do pay the cost. You have to define the structure up front and tell the system about it. Yeah, so I also wanted to point out HBase, especially when you talk about sort of analytical queries. You can't really do analytic queries in HBase in the way I would describe an analytic query, right? HBase, best of my knowledge, you can do basically key scans. So you can scan big ranges of keys, and it's also very good at point lookups, which I'll talk about later. But just because it has sort of a structure, it doesn't really help query performance a whole lot. All right, so the next thing I'm going to talk about is load versus queryability. This is like how long it takes you between when you load the data to when you can actually query it. So the very low end, there's HBase, right? Like if you need your data back in milliseconds, HBase or some of those similar key value stores is good. Systems like Vertica and other parallel databases work quite well for like hundreds of milliseconds. I know Dan said 5 minutes, but I suspect that has more, there's more to the load than just loading it into the system, right? There's also a more significant ETL process, but you know, it's the right order of magnitude. And then the Hadoop and the Hadoop-based systems have a significant startup overhead for their jobs, right? Like, you know, order minutes or so to run a job. So if that's important to you, that's an important sort of distinction, I think. Also, let's talk about consistency, because that often gets thrown out in these big distributed systems. You have to come up with some story of how you keep the data consistent across the different across different tables, right? So systems like databases give you those ACID guarantees that whatever, you know, that you can have a consistent view of your data. Systems like HBase don't give you a fully consistent view, but they help you out. Like for a certain key, they'll give you strong consistency guarantees that you know what the value of the key should be, but no cross-key consistency guarantees. And then the Hadoop-based systems typically leave it up to the application to figure out what that notion of consistency is and enforce it, which frankly is a very reasonable trade-off in some analytic systems, but it's harder to reason about and program against. Finally, I want to talk about single row operations, because this is actually a significant trade-off that, you know, if your workload is single row operations, that's what you use HBase for, some of these other technologies, right? If you have large numbers of incoming single row inserts or updates, HBase is great. Or if you've got lots of little record lookups, right? But these other analytic systems are designed to crunch huge amounts of data, not huge numbers of transactions a second, huge volumes of data, right? So that's why they're really good at aggregating and whatnot. So yeah, like I say, I think it actually excels at this. So I think with that, I'll spend my last minute with questions if there is any, if there are any.
Are there any questions for Andy?
On the cost slide, I was wondering if you had any data on that in terms of the CapEx cost versus OpEx cost on different systems?
I feel like you always lie with statistics. It seems like every customer or every potential competitor has a spreadsheet, right, that tries to estimate how much money you spend up front versus how much money you run over time. And from what I've been told, there's an advantageous financial accounting reason why certain, especially large mature companies, want to do an upfront capital expense, because it has a more favorable accounting treatment than ongoing operational expenses. But frankly, I'm also not an accountant, so I don't know exactly what that is.
So, Andrew, I would challenge this key value store stuff. I've been sitting outrageous for at least a couple hours. So there's a lot of myth around how fast MongoDB is. And a lot of people, I don't know whether people love MongoDB because it's JSON as a data model. But for 20 years, the relational vendors focused their entire attention on OLTP benchmarks.
That's right.
Those are key value lookups. Look up an account, do a debit, put the value back.
Yep.
And there's so much crap in this community about how fast things like MongoDB are compared to all the relational vendors. It's stunning to me that people don't actually look beneath the hype. So
I think the story is that at least the perception is systems like the new NoSQL key value stores scale, whereas relational databases don't because they have a single shared disk. And I know there's new parallel databases that claim to do better, right? But
all the major transaction processing workloads in the country run on standard relational products.
No doubt about it.
Oracle, Microsoft, et cetera, IBM DB2. And it's just like, I just don't believe that this key value stuff has the traction that it has. So, okay. I don't know if you're...
I'm not going to justify key value stores' existence, I don't think. That's another company's job.
Okay, so let's thank you, the speaker, again.